This is Juan Berciaga doing two standards, one standard on vocal tracks and the second one is on microphones. First I want to start talking about vocal tracks. Here we have our lungs, and you have your airway, and then you have your vocal folds, and then it keeps going, and you have your nasal cavity, tongue, and lips. Um, you have control over four things that produces sound, which is your lungs and the amount of pressure it gives off your vocal folds. Talk about that later. And then you have your shape and opening of the mouth. With with control of all four of these, you can create a large variance of different sounds. If you maintain lung pressure, your vocal folds, and the shape, and change your opening, it would sound something similar like and if you still maintain your lung pressure, vocal folds, but change your shape and opening, it would sound something similar like aum, aum, aum. And then the shape of your mouth is really interesting because it sort of acts like a resonator chamber. So if you plot it on a plot spectrum on Audacity, you get these peaks here, and then you can get these different types of emphasis. You can get one large emphasis, or you can get different double emphasis. And in class, we talked about how opera singers can change their emphasis somewhere out in the blue, somewhere out far. There's just something special about that. And the shape is kind of a since the shape is a kind of a resonator, it's in the sense of aspects of the original sound, which are from the vocal folds. They're located right here. If we just had the vocal folds, we would all sound like buzzing bees. The vocal folds make a buzzing sound, and the shape of your mouth emphasizes the sound, such as your vowels a, e, I, o, u. When you hear them all, they all have the buzzing sound. And next, the lung pressure here just focuses on loudness, so you can give different types of pressure when you talk. So you can be talking out loud, and then you're just giving off more air pressure. But then how your vocal folds and lungs work is for your vocal folds, you have these membranes that are connected to tissue muscle. They can be relaxed or closed shut. They are all held by the same amount of stiffness, which keeps them open or shut. And that's what you can control. What happens? What happens is when you release air pressure and something happens to your vocal folds, or it's called the Bernoulli effect. So when you blow out a pulse from behind your vocal folds, they get stuck together. So the vocal folds are sort of like flaps. And after when they get stuck, air pressure builds up behind it, and then when there's enough air pressure, it opens back up, and then it closes shut again. And then, depending on the stiffness, you have a cycle, and the way it repeats, the repetition of that cycle gives off a specific frequency. And then I would next start talking about the microphones. So when you speak into, well, right here first we have the dynamic microphone, which is magnetism. So when you speak into this speaker, the microphone, I'm sorry, um, you have your cone and you have your coil and you have your magnet. When you speak into the either the coil or the magnet, one of them has to shake to send a electromagnetic reading to the down the coils to the computer and whatnot. But if you remove this here and just have this, you still get the wiggle, but you wouldn't get any like electric readings going down, so nothing would happen. But then if you have both and it's way out here, you'll still get the same. You wouldn't get the same effect. You would get the same effect if you had both here. You would still get the wiggle, but if it's far out here, it would be weak. You have a weak signal. And then here we have the condenser microphone, which are just basically two plates that are positive and negatively charged, and you have the voltmeter that are just basically measure how happy and unhappy the charges are. So if you, well, let's start talking about how to make a plate negatively charged. It's just like grabbing a balloon and rubbing it against your head and have this static so you have it negatively charged. Well, if you yell at this, you want one plate to move so you can get these readings, so the volt chargers to get a reading. So when they're close, they're happy, and when they're far apart, they're sad. So when you yell, you want one of these to move up and down to get a, so the voltmeter can read it to give off a electric reading. But you could also have two negatively charged plates, but they would both move in unison, going up and down together. So you would want to make one of them heavy. So it would probably, you just probably, I don't know, mount it to some heavy metal and make this one probably aluminum, something light. And what would be different about them, they both act the same, but the different thing is when you plot it, when you record it, they're gonna be the same reading, but they're gonna be opposite of each other. So the negativity charge would be negative, so right here. And then when you have the both negative and positive charges, you would have the same reading, but up here. And that is it. Thank you.